Hey everyone, thanks for joining the Flight School session today. My name is Samhita and I'm with the Union AI team. Union AI is a company that offers orchestration solutions. We help you get value out of your data and ML use cases. And Flyte is an open source product we contribute to and maintain. Today, I am going to arm you with the skills to help you prepare your data and ML pipelines for both development and production. If you have any questions, please do post them in the chat. All right, let's get started. First, learning objectives. In this session, you will learn how to simplify the pipeline development lifecycle, build custom images without using a Dockerfile, explore different methods to register flight tasks and workflows, make data and ML pipelines production ready, and finally, you will learn how to use projects and domains to facilitate team collaboration and the transition from development to production. The outline of the session is as follows. First, I'll provide a brief introduction to flight tasks and workflows, and then we will look at how to simplify local development, simplify iteration on a flight cluster, how to make pipelines production ready, and how to transition pipelines from development to production. The assumption is that you know what Flyte is, at least kind of familiar with what it does and what it is capable of. And this session is geared towards developers and pipeline builders, focusing on their perspective rather than in an infrastructure viewpoint. Now let's look at flight tasks and workflows. A flight task is a core building block for type safety, statelessness, and reproducibility. And a flight workflow is basically a domain-specific language or DSL that builds an execution graph that uses tasks as the building blocks for more complex pipelines. So here are the visualizations. Task is version. It is containerized. It accepts inputs and produces outputs, which have to be annotated with types. And a workflow is a collection of tasks or the workflows themselves. So here there are 4 tasks, and the dependencies between the tasks need to be defined. And a workflow is versioned. Data flow is a first-class citizen, and a workflow accepts inputs and produces outputs, which need to be annotated with types as well. So here's an example. This particular workflow defines the dependencies between these tasks, and you should be able to run this workflow locally, just like a Python function. And yeah, here's the output. And this particular Python file has all the flight tasks and the workflow. And you should be able to run this locally as well, just like a Python script. And yes, here's the output. And in summary, a task exhibits the following characteristics. It's version, it has a strong interface, and it is independently executable. And workflows can be written as Python functions, but it's important that you distinguish tasks and workflows. A tasks body executes at runtime on a Kubernetes cluster. And in contrast, a workflows body doesn't perform computations. It's used to structure tasks. A workflows body executes at registration time during the workflows registration process. So that's when the structure, the dependencies between the tasks is determined. And here are a couple of resources that you can take a look at. Next, let's look at how to simplify local development. Local development is a crucial prerequisite before promoting your data and ML pipelines to production. It facilitates faster debugging, allows for rapid experimentation, and consequently instills confidence in you when you want to productionize your pipelines. So what is local development in Flyte? It involves executing tasks and workflows locally right on your terminal as a simple starting point. For instance, you should be able to run your code as a Python script, as we've seen earlier. Now, this should essentially be your first step in testing and debugging. However, with Python, you don't get to leverage all the benefits offered by Flyte, such as type checking. That's when you will want to transition to Flyte native commands like pyflyte run. PyFlyte run is the simplest command to test your tasks and workflows locally. So here's an example of a PyFlyte run command wherein I am specifying the name of the Python file followed by the workflow and the inputs that I want to provide to the workflow. So let me just run this real quick. So this runs the code locally. And here's an example of running a task locally. This task doesn't accept any input, and hence I'm not providing the input. And yeah, I should be able to run this locally as well. And these are all the options that are supported by PyFlyte run. There's project, domain, destination, directory, and so on and so forth. And yes, yeah, you need to install the required dependencies locally before running your code in case your Flyte tasks and workflows require libraries besides FlyteKit and the ones that it installs by default. And local caching. So Flyte by default provides local caching to store the outputs of your executions locally. This should speed up your executions. And I also want to quickly talk about agents. And a Flyte agent is a long-running stateless service that can be used to execute tasks. It reduces the overhead of creating a pod for each task and enables interactions with external services. So whenever you need to interact with external services from within Flyte and want to test it locally, you can use agents. So agents are helpful to test calls to your external services locally. External services meaning, say you want to call a BigQuery service, right? So you can use an agent, which we already support. You can use that to kind of test it locally first while developing, and then you can also deploy it in production on a Flyte cluster. You can run an agent just like any other Flyte task or workflow using the PyFlyte run command. And now, how to simplify iteration on a Flyte cluster. So running code locally on your terminal is beneficial for catching code-related bugs early on. For quick iterations or access to GPUs or data lineage and overall leveraging everything that Flyte has to offer, you need to run code on a local Flyte cluster. Now, this should pretty much set the standards for running your code on a production Flyte cluster. The good thing is you just need to add the remote flag to your PyFlyte run command. But before that, I am importing two environment variables. The flytectl config points to the cluster, and the image has all the additional dependencies that my code requires. So I have built an image already, a Docker image already. So yeah, and here's the PyFlyte run command. I am adding the remote flag and also the image. I'm sending the image because this workflow has some additional dependencies. If that isn't the case, you don't need to provide an image. And let me run this. And now let me go to the console. Right, here's the console. And yeah, an execution got triggered. Let me just go to a previous run. Here it is. Here's the DAG. And here's the timeline view. So you should be able to evaluate the duration of each of your Flyte tasks over here and identify potential bottlenecks. And here's also a breakdown of the time consumption. And yeah, you should also be able to rerun a task, recover, relaunch. Recover is available after, say if a workflow fails. If an execution fails, that's when you can recover the workflow so that the execution will begin from the failure node. And you should be able to view the inputs and outputs. And yeah, let me go back to the Jupyter notebook. And now let's decode the power of remote. Let's look at the features that we can unlock with the remote flag. Every task in your workflow runs in a Kubernetes pod now. There's data lineage, so you get to view the data lineage, meaning you can track the movement and the transformation of data. You can recover a partially successful run, as I've mentioned before, in case your execution fails. Your workflow and tasks are versioned. Executions are immutable. Type checking, so the type checking usually happens at compile time, and it can also happen at runtime. And timeline view, and then there's parallelism. Flyte tasks are inherently parallel to optimize resource consumption and also improve the performance. Now, what's image? The workflow we are using requires additional libraries besides FlyteKit and the one it installs. The image parameter is used to supply the Docker image that Flyte uses to spin up containers in which the workflow code runs. If you want to avoid the hassle of building a Docker image, you can use image spec. So here's an example of image spec wherein I am specifying the name of the image, the registry, here it is the local registry, and the packages that I want to install in the image. And then I am specifying that as the container image in the concerning task decorator. Now, let me run the code. So first I am creating empty context. This is kind of necessary when you are using the local registry. And then I am running the PyFlyte run command. I'm executing this. So here I am not providing any image because the image is defined in the code itself. Now let me run this. And this, since the image is already available, it's just gonna skip building. And let me go to the console now. Yeah, here's the image that is being used for this particular, container. Next is caching. Caching is especially useful during quick iterations while developing pipelines. None of us wants to spend more resources and time than needed running an execution which has already, succeeded again and again. So here's how you can set cache. You just have to say cache is true, and you also need to specify the cache version in the task decorator. So cache version is useful when you want to invalidate cache. And then there's decks. Decks allow you to gain visibility into your tasks. You can use Flyte decks to render visualizations. So you can render data frame, markdown, box plot, image, table, source code, and anything that is HTML renderable. Here's an example. Let me just run this. Here's the code for that, wherein I am enabling the deck. Also using image spec here because I want to install the Plotly package. Here's the code. And in the end, I am calling the deck and rendering markdown and also HTML. Let me go to the console. Yeah, it got triggered. Let me go to the PCA plot. Yeah, so here's the Flyte deck that got rendered. All right. So overall, decks from the perspective of streamlining execution on a Flyte cluster allows you to debug faster and enables you to quickly grasp how your workflow is faring. And now let's look at registration. So Flyte supports like 3 registration patterns. PyFlyte Run is one of them. PyFlyte Run incorporates packaging, registering, and launching a workflow into a single command. It is designed to be a quick and an easy iteration tool to get started with Flyte or test small self-contained scripts. PyFlyte Run also leverages fast registration. How? When a script is executed using PyFlyte Run, the script is bundled up and then uploaded to Flyte admin. Now, when the task is executed in the backend, this zipped file is extracted and then utilized. Now, fast registration is useful when you already have a container image hosted in your container registry of choice, and you change your workflow or task code without any alterations to your system level or Python dependencies. In contrast, regular registration expects the user to embed the user-defined workflows and all the dependencies into a Docker image. So everything in one Docker image. This method ensures that the workflows are fully containerized, making both the dependencies along with your workflow source code immutable. So fast registration is useful when you want to quickly iterate on your workflows. And when the dependencies are going to remain the same, but you just want to kind of work on the code. And yeah, here are the registration patterns. So when you want to iterate on a single task or workflow, you can use Flyte run. When you want to iterate on a project that has like multiple tasks and workflows, you can use Flyte register. Flyte register supports both registration and fast registration. And then there's also Flyte package and Flyte register that you can use for your production flows. Now, you can also use Flyte register for your production flows, but you may want to consider Flyte package and Flyte register if you are working with multiple Flyte clusters, since it uses a portable package when you're deploying workflows to a production context and when you want to test your Flyte workflows in your CI/CD infrastructure. When iterating on your workflows, fast registration is the go-to option. Now, let's look at how to make pipelines production ready. Your pipeline's working fine, and now you want to productionize it. But first, let's look at what's productionizing a pipeline. You need to ensure that your pipeline is now ready to handle real world scenarios. From the perspective of data and ML pipelines, this can mean any of the following: ensuring your pipelines have the necessary resources, receiving notifications when there's a workflow failure, setting a cadence at which your workflow has to run, establishing a logging system, providing access to GPUs, and adding secrets. So first, let's look at task resources, how you set task resources in Flyte. The following attributes can be specified for a resource: CPU, memory, and GPU. Here's how you can specify the resource. You just can say CPU 1, mem is 100, MI, and then yeah, you can also specify GPUs, the number of GPUs that you need. And yeah, there's requests and limits. So task can possibly be allocated more resources than it requests, but never more than its limit. Requests are treated as hints to schedule tasks on nodes with available resources, whereas limits are hard constraints. Now let's look at notifications. So if a workflow fails in production, you want to be notified of the failure, right? That's when this comes in handy. Flyte supports getting notified via email, PagerDuty, or Slack. So here's how you can set up notifications. You need to set them up in a launch plan. Here, I am setting up 3 notifications. So one is when a workflow fails, a notification is sent to these 2 email addresses. Whenever workflow succeeds, an email is sent to this particular address. And to set up notifications, you can use SendGrid mail servers. Next, let's look at scheduling. Launch plans can be set to run automatically on a schedule using the Flyte native scheduler. Here's an example wherein I have configured the cron schedule to make sure that the workflow runs every 2 minutes, and I am also specifying the default inputs that need to be used when triggering the workflow. And yeah, here's how you can activate the schedule. So you need to activate it after you define the schedule. So I just am running this command. I just say Flyte register the name of the Python file followed by activate launch plans flag. Let me just run this command. So this should activate the launch plan. Let me quickly go to the console. And here it is. Yeah, so this activates the launch plan. This runs every 2 minutes, and this is the default launch plan that gets associated with every workflow that you create. All right, now let me deactivate the launch plan. So here's how I do it. I just say Flyte launch plan followed by the name of the launch plan and the deactivate flag. Let me run this, and this deactivates the launch plan. And now logging. To debug your workflows in production, you want to access logs from your tasks as they run. These logs are different from the core Flyte platform logs and are specific to an execution. Some examples of log aggregators include cloud-hosted solutions like AWS CloudWatch, GCP Stackdriver, Splunk, Datadog, etc. I have attached a resource so you can take a look at it if you want to know how to set up logging in your Flyte deployment. And GPU. So most ML training jobs typically require a GPU, right? And you want to ensure that you assign the right GPU to your training job. So here's an example. So say you want to assign a T4 GPU to your task, to your training job, you just can say the accelerator equal to T4, and there are like a bunch of accelerators that we support. And yeah, you can also specify the limits and the requests, basically specify the number of GPUs that you need. And then there's secrets. You don't want to expose the secrets that your pipelines require, especially in production deployment. So here's an example of how you can set up secrets. You can configure a secret management system like AWS Secret Manager or Vault to inject secrets. And yeah, that's all it takes to make your pipelines production ready. And now let's look at how to transition pipelines from development to production. Domains allow you to transition pipelines between different environments, providing an abstraction to isolate resources and feature configuration for each deployment environment. Examples of domains include development, staging, and production. You can specify lower resource limits on the development and staging domains than on production domains. And you can also use domains to disable launch plans and schedules on development and staging domains, as these are features which are typically meant for production domains. So here's an example of how you can provide, a the domain, the name of the domain in the pyflight run command. So here I am specifying development. So this basically triggers the workflow in the development domain. And yeah, now say I want to trigger a workflow in the production domain. That's when I specify the name of the domain as production. Let me quickly run this and let me go to the console. Let me select the production domain. Here it is. So this triggers the workflow in the production domain. And yeah, you can also update cluster resources by adding the required quota to a YAML file as follows. So here's how you can do it. You can specify the CPU and memory quota and domain and project. So this quota gets allocated to this particular project domain namespace. And then you can run flytectl update cluster resource attribute followed by the name of the YAML file, whichever has this config. And yeah, a workflow that's production ready can also run in the development domain. All the features we have seen are especially useful when running in production, but it should work either way. And you should also be able to reference tasks and workflows from other projects and domains. So say you are in the production domain and you want to access a workflow that's in development domain, you can use a reference workflow, reference launch plan, or reference task for that purpose. And yeah, you have made it through to the end of this module. So to recap, we have briefly explored the basic constructs of Flyte. We have looked at tasks and workflows, and we have understood how you can develop pipelines locally, recognized how easy it is to run workflows on a Flyte cluster, understood which features to leverage to make your pipelines production ready, and learned how to transition pipelines from development to production. And yes, thank you so much for sticking around until the end of this session. Do check out our documentation, join our Slack in case you have any questions or if you just want to join the community, and check out and start the Flyte repo. And we will share this notebook with you all in a follow-up email. And yeah, thank you. Thanks, everyone.